Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so I actually want to continue to discuss trust, okay, indeterminate trust, okay, using stiffness method. So we are going to analyze another trust example. Okay, so let's focus on the trust. So this is the trust. Okay, so by looking at this trust, okay, we can see that the trust has four nodes. Okay, the trust has four nodes. Okay, the trust has four nodes. Okay, node number one, node number two, node number three, and node number four. One here, two, three, and four. There are four nodes. So this four node has been labeled in the diagram. And always remember, two nodes, when combining two nodes, we have one element. Combining two nodes become one element. Okay, combining two nodes become one element. Okay, combining two nodes become one element. So there are three elements. So we have element one here, element two, and element three. Okay, so we have four nodes and three elements. We have four nodes and we have three elements. Okay, so every time we want to analyze trust using stiffness method, we have to make sure that in the diagram, okay, the diagram must have uh, the node number, the element number, and after that, we have to make sure that there are arrow. Okay, each element must have arrow, and and the arrow is always parallel with the member. In any direction doesn't matter. We can put in any direction that we like. And by looking at this truss, the arrow is also given. The arrow is also given like this, and the arrow parallel with the member. Okay, like this. So why arrow is important? Why arrow is important? Because the arrow, by using the arrow, we can identify near and far end condition. This is node, elements, okay, nodes. Okay, why arrow is important? Because from arrow we can identify near node and far node, near end node and far end node. Arrow is very important, because from near node and far near end node and far end node, we can calculate lambda x, lambda y, or we also call it as cx and cy. Okay, arrow. Okay, so after that, okay, number one, we must have node number. Number two, we must have element number. Number three, we must have arrow, okay, in order to identify where is near end node, where is far end node, and the arrow is always going to the far end, going towards far end. Means that if arrow is like this, okay, so this one become far, because always going to the far end. So this one become near for element number one. Okay, so beside these three, okay, we have to put number four. Number four, what is another important criteria that we must put into the diagram before we can start analyze. Okay, the element stiffness matrices and the structure stiffness matrix. What is it? It is coordinate. It is coordinate. And always remember, we will put coordinate based on the global system. We will put coordinate based on the global system. Okay, and we will put coordinate at each node. And from these four nodes that we can see in this truss, we have to choose one node as origin. We have to choose one node as origin. So whenever we choose node number 4 as origin, we will get node number 1, node number 2, and node number 3, okay, with positive coordinate. Positive coordinate. So if 4, okay, if node number 4 is origin 0, 0, so we can get node coordinate for node number 3 will be 0, 3. Okay, and coordinate for node number 1, okay, coordinate for node number 1 is 4, 3. And last one, for node number 2, based on origin at node number 4, okay, so the coordinate for node number 2 is 0, 7. 0, 7. Okay, clear? Okay, clear. Okay, now number 5. Criteria number 5, that is very, very important. The most important part, okay, is actually the degree of freedom level. Degree of freedom. So always remember, degree of freedom, okay, will be depend on the nodes. Now means that we know that in trust there are two nodes. There are two degree of freedom per nodes. There are two degree of freedom per nodes. Means that if we have four nodes, so it is 4 times 2, total is 8 degree of freedom. Okay, and this 8 degree of freedom, okay, represent 6, okay, represent 8 position. 8 degree of freedom represent 8 position in the diagram. 8 position, from position 1 until position 8. And this degree of freedom, okay, we have to divide into two condition, which is called as unconstrained system and constrained system. Unconstrained system and constrained system. And okay, under unconstrained system, okay, there are unknown displacement. There are unknown displacement which we label as du. And under constraint system, there are qu, unknown reaction. And actually this du and qu will be the output for stiffness method analysis. Du and qu will be the output for stiffness method. Okay, and between d and q, okay, du will be determined first, followed by qu. We cannot determine we cannot determine qu without du. In order to calculate qu, which is reaction at the support, q represent force. So qu represent u, the small u represent unknown. So qu is unknown reaction forces. Okay, the small u represent unknown. Okay, the small u represent unknown, q represent forces. So qu is reaction at the support. Q is reaction at the support. Du, okay, u represent unknown, d represent displacement. So it is unknown displacement. Okay, so we have to identify number of unknown reaction. We have to identify number of unknown reaction in the system by looking at the support in the system in this truss. And by looking at at this truss, there are 3 pin support. 3 pin support represent 6 unknown reaction. Represent 6 unknown reaction. Means that there are 6 unknown reaction, and since we know that the total must be 8, so the remaining is 2, which is located under du. So what does this mean? So this means there will be 2 unknown displacement that we need to calculate, and after that we will use this unknown displacement d1 and d2 to calculate unknown reaction. Okay, don't forget label we should label start from, for the label we should start from unconstrained, means we have to complete labeling unconstrained first, then only we continue with constraint. Okay, means that numbering in total there are 8 numbering: 1, 2, 3, 4, 5, 6, 7, 8. In total there are 8 position. Okay, and we must label number 1 start from unconstrained, and from this, okay, from this we know that 1 and 2, 1 and 2, okay, will be located in unconstrained system. Okay, these two represent position 1 and position 2, position 1 and position 2, and 6, and this 6 represent 3, 4, 5, 6, 7, 8, because degree of freedom represent position. There are in total 8 position. Okay, and du and Q represent unknown value. Means that in unconstrained system there are d1 and d2, d1 and d2. And for QU, the label for QU will be started at at number 3, position number 3. So there are Q3, Q4, Q5, Q6, Q7, Q8. Okay, so it is Q3, Q4, Q5, Q6, Q7, Q8. Okay, okay, so the output, the first output that we need to calculate, okay, is displacement. There are 2 displacement, d1 and d2. There are 2 displacement, d1 and d2. d1 and d2. So what is d1? What is d2? What is d1? What is d2? Remember, 1 and 2 represent position. 1 and 2 represent position. Okay, so actually in this question, the labeling is given in the question. But normally, the labeling is not given. So when labeling is not given in the question, what you need to do is you have to label on your own. You have to label from 1 to 8 on your own. Based on your understanding, label which is 1, which is 2 until 8. Okay, so how to do that? Okay, I want to sketch the diagram right here. We have, okay, like this. Let me draw like this. Okay, this is element 1, element 2, element 3. This is element 3. Okay, now okay. Okay. So I want to paste 2 times. I want to paste 2 times, represent thing, one unconstrained and one constraint. Okay. So okay. Okay. So I have actually sketched the element, the truss. Okay. So now we are going to label. We are going to label the degree of freedom. We are going to label the degree of freedom. Start from 1 until 8, and always remember we will start numbering from unconstrained. We will start numbering at unconstrained. So which is unconstrained? This is unconstrained system. The first one will be unconstrained system, followed by constrained system. Unconstrained will be labeled first because the unknown displacement. Okay, the unknown displacement, uh, there are unknown displacement in unconstrained system, and unknown displacement is the first output that we need to determine. Okay, so what we need to do? Okay, and we know that there are 2 degree of freedom. Okay, these 2 representing degree of freedom. Okay, these 2 is representing degree of freedom, means that under unconstrained there are 2 degree of freedom. 2 degree of freedom. Under constraint system, there are 6 degree of freedom. However, by looking at the original diagram, okay, by looking at original diagram, the easiest way to label, the degree of freedom, okay, should start from constraint system, because under constraint system there are unknown reaction, and we know that there are 6 unknown reaction, because we know that there are 3 pin support. Labeling unknown reaction due to labeling unknown reaction, okay, due to support. Okay, I believe everyone can understand, because we always do it conventionally. Every time we want to analyze reaction at the support, when we analyze structure, determinate structure, we will draw the free body diagram. And when we draw the free body diagram, the first thing that we do is we label the reaction at the support. Okay, now we will label reaction at the support, but we must use the direction according to the sign convention x and y. X and y component, and x and y component must be in right direction and in upward direction respectively. Okay, so what we need to do? Okay, there are 3 pin support. There are 3 pin support. So here, okay, wait. Okay, again. Okay, again. Okay, I will use this. Okay, to draw the degree of freedom in x and y component. Okay, it must be in right direction and y direction, x direction and y direction, x component and y component. and it should be in opposite direction. How to it? Not this one. It must be upward. Again, this direction. Can I rotate this? Cannot. Can I rotate this? Okay, can. Okay, so this is the degree of freedom, okay, in x and y component. In x and y component, so we must put six in constraint system. We must put 6 in constraint system and 2 in unconstrained system. We put 6 in constraint system represent 6 unknown reaction due to support. Okay, due to support there are 6. So we put 1 here. Okay, not 1, 2. 2 here. Because after this, I want you to okay to understand is at each position 1 from 8, okay, you should look at the position according to forces and according to displacement. Means that D1 until D8 and Q1 until Q8, okay, will have the meaning. It is physical meaning. Okay, so there are six unknown reaction. Okay, 6 unknown reaction equal to 6 unknown reaction equal to 6 degree of freedom in constraint system. So this is unconstrained. Okay, for unconstrained, I want to change the color. Okay, so the blue is for the degree of freedom in unconstrained system. In unconstrained system, and the red label is for the constraint system 6. It is 6 representing reaction at the support. Okay, so now we will start label. So always label 1 from unconstrained. Okay, always label 1 from unconstrained. Finish the unconstrained system first, then only continue with constraint for the labeling. So means that we should label 1, 2 like this. Okay, 1, 2 means we will start with X first, 1 and 2. Okay, complete unconstrained, then only we continue to constraint system. So we continue 3 for how the question. Okay, same. Actually, you may label in different way. Maybe your 3 you want to put here, doesn't matter. Okay, doesn't matter because it is just the position. Okay, this is 3, 4, 5, 6, 7, 8. Okay, 3, 4, 5, 6, 7, 8. Okay, so in the first part of this video, I actually want you to understand about okay, the five criteria that you need to make sure exist in the diagram. And normally the most important, and this one must be correct. This one must be correct. must be correct to make sure that your analysis later on will be correct as well. Okay, and most important is degree of freedom. And whenever we want to label degree of freedom, we have to make sure that okay, we label it according to unconstrained and constrained system. So in order to draw or to label it correctly, I want to suggest you to sketch, okay, like what I am doing right now. I will sketch separately unconstrained and constrained system, and I will label the degree of freedom. Label the degree of freedom. Start from reaction at the support. Start from the reaction at the support. And because we by looking at the diagram, by looking at the support, we know number of unknown reaction. And always remember, number of unknown reaction equal to number of degree of freedom in constrained system. So now we have label one two, okay, 1 2 under unconstrained system, followed by 3 4 5 6 7 8 under constrained system. Okay, and in this diagram and in the question, okay, the degree of freedom label is given, are given. All the degree of freedoms label are given to you. But if it is not given, you have to do like what I am showing. Okay. And 8 a degree of freedom representing 8 position. 8 degree of freedom. 8 degree of freedom represent 8 position. 8 position of what? Of Q and D. Okay, 8 position of Q and D. Because remember the output for stiffness method, okay, the output for stiffness method are displacement and forces. Displacement and forces. And this displacement and forces, we relate into each other by force displacement equation. Force, it is force displacement equation. And this is also called as stiffness equation. Stiffness equation. Stiffness equation. So what is the equation? It is Q equal to KD. Q is equal to KD. And always remember stiffness. Stiffness method is actually based on the matrix. We will solve all values by using matrix. Okay, it is matrix multiplication. Okay, so Q will be written in matrix form. D will be written in matrix form. K is also matrix in matrix because K is the structure stiffness matrix. Okay, so this K is structure stiffness matrix. Okay, K is structure stiffness matrix. Determine the structure stiffness matrix using element stiffness matrices. And for the element stiffness matrices, I have actually discussed that in my previous video based on example 14.1 Hibbeler. Okay, so what is Q and D? Q. Q is nodal. This nodal forces. Nodal forces. Q is forces. Okay, nodal forces. D D is nodal displacement. D is nodal displacement. And remember, all Q, K, and D in matrix form, based on eight position, 8 degree of freedom, 8 position, which is 8 degree of freedom. This is 8 degree of freedom. Okay, 8 degree of freedom. It means that the structure stiffness matrix K, because degree of freedom in total is 8, we will produce structure stiffness matrix, which is 8 by 8 matrix. 8 by 8 matrix. And for nodal forces, there are 8 position. From 1 until 8. It means that there are Q1 until Q8. There are Q1 until Q8. Q1 until Q8. And nodal displacement also has 8 position. It is D1 until D8. And Q1 until D8, D1 until D8, okay, should also be written in matrix form. So how? So Q equal to 8 position, 1, 2, 3, 4, 5, 6, 7, 8. And also we have D, nodal forces. We must write in matrix form as well. There are 8 position. 1, 2, 3, 4, 5, 6, 7, 8. And number of position come from number of degree of freedom. Okay, Q and D, if we refer back to this. Okay, so 1 and 2 here represent D1 and D2. D1 and D2, and these are the unknown. And 3 to 8, Q3, Q4, Q5, Q6, Q7, Q8, also unknown, because there are 6 unknown reactions. Okay, so in the matrix D and Q, D1 and D2, as well as Q3 until Q8, okay, we will write it in symbol. So we write it like this. Okay, D1 unknown, D2 unknown. And continue with, because this is unknown displacement, DU. Unknown displacement, DU. This is DU. Okay, the two value, okay, are DU. Okay, and there are unknown reaction. There are 6 in total because there are 3 pin support. Okay, these are Q3, Q4, Q5, Q6, Q7, Q8. And these are QU. Okay, so okay, by understanding general knowledge about the support, by understanding general knowledge about the support, at support, at support, there is no deflection. At support, there is no deflection. So what happened is for displacement at position D until position 8 due to support displacement D3, D4, D5, D6, D7, D8 will equal to 0, 5, 6, 7, 8. Okay, all displacement at position 3 until position 8 will equal to 0 because of the support. Because of the support. Okay, and okay, please look at this carefully, and we can see that between Q and D, there are opposite condition. They are opposite condition. For example, okay, if in Q at position 3 until position 8, we put label because Q3 and until Q8 are the unknown. And in opposite condition in under D, okay, at the same position, but it is D. Okay, D, we have to put value. So one is a Q, one is known, one is unknown. D will be known value, and the known value of displacement due to support will be 0 because no movement at support. No movement at support. Okay, same goes to position 1 and position 2. Position 1 and position 2. At position 1 and 2, for D, there are two displacement. Two displacement, unknown displacement. Unknown displacement. It means that in opposite condition, under Q at position 1 and position 2, it must be known value. It must be known value. Do you get what I mean? Okay, look at Q and D carefully. Look at Q and D carefully. Q3 until Q8 are unknown because it is known versus unknown. It is known versus unknown. Known versus unknown. You get what I mean? It must be in opposite condition. It must be in opposite condition. What does it mean? Okay, if Q3 until Q8, all these are unknown at same position 3 to 8 under displacement, okay, we must put known value. And known value for displacement at position 3 until position 8 will be 0 because there's no movement, there's no displacement at support. And if we look at position number 1 and number 2 for both Q and D, if D1 and D2 are the unknown, at position 1 and position 2 for Q will be known value. Known value. We cannot put the Q1 and Q2 because 1 and 2 we must put forces. So what is Q1, what is Q2? Q1 and Q2, 1, 2, 3, 4, 5, 6, 7, 8. All this refers to position of degree of freedom. So refer back to the diagram. 1 and 2 represent 1 and 2 represent, this is 1, this is 2. 1 and 2, 1 is in horizontal component, 2 is in vertical component, and this 1 and 2 are located at node number 1. Located at node number 1. What does it mean? Q1, okay, it has what we call as physical meaning. 1 and 2, Q1, Q2. Actually, Q1, Q2 until Q8, but Q3 until Q8 are the reaction at the support. So what is the value for Q1? We must read from the diagram, from the forces given in the diagram, from the forces given in the diagram. Okay, look at the note number 1. Look at note number 1 carefully. Okay, Q1, Q1 is force in horizontal direction. It is a horizontal force at node 1. Horizontal force at node 1. It is a horizontal force at node 1. Q2, it is a vertical force. Q2, vertical force at node number 2. It is a vertical force at node 2. So read the value in the diagram, given in the diagram. Is there any horizontal force given at node number 1? No. There is no horizontal force given. There is no horizontal force at node 1. So if there is no value which is subjected at 1 in x component, x direction, it means that Q1 will be equal to 0. Q1 equal to 0. Q1 equal to 0. Non-value, but the value is 0. It is non-value, but it is 0 value. Okay, now Q2. What is the physical meaning of Q2? Physical meaning of Q2. Okay, Q2 is a vertical force at node 1. Q2 is a Q2 is a vertical force at node 1. Q2 is a vertical force at node 1. Okay, look back at the diagram. Okay, look back at the diagram. Okay, vertical force at node 1. What is the value? Vertical force at node number 1. What is the value? Okay, yes, it is negative 20. It is negative 20. And it is negative because it is opposite with sign convention. Negative because it is opposite with sign convention. This is sign convention. This is sign convention. Sign convention, and the force is in downward direction, opposite with sign convention. So the value for Q2 equal to negative 20. Okay, equal to negative 20. Okay, so this is very important. This is very important for you to understand about how to fill in the value, okay, or the symbol in nodal forces, nodal displacement written in matrix form. This is very important because even though the first step of analysis will be the establishment of the stiffness matrix. However, stiffness matrix will be used in the stiffness equation. Q is equal to KD, and without understanding about what is nodal displacement, what is nodal forces, we cannot continue until the end of analysis. Okay, so this is the first part of my sharing session about this example. Even though I have actually listed here the question, and these are the question that actually we need to do in analysis of structures using Truss using stiffness method. Okay, so we will calculate, we will establish, we will form, okay, the structure stiffness matrix that 8 by 8 matrix. Okay, why we need to do that? Because from that we will calculate unknown displacement and unknown reaction. So we should be able to write nodal displacement and nodal forces in matrix before we rewrite into the stiffness equation. So you rewrite into the stiffness equation, and after that we will solve for the unknown displacement and for the unknown reaction. Okay, so I will end my sharing session about the first part of analysis of this trust. Okay, inshallah we will continue the second part B. Okay, in the next session. Okay, so that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.